Welcome to this video on planning for migration. After watching this video, you will be able to explain the need for migration, define the key phases in migration planning, discuss the potential challenges in migration planning, and explore tools and frameworks for migration and modernization. As technology rapidly advances, organizations are under constant pressure to update their IT infrastructure to maintain a competitive edge. Migration planning plays a critical role in this transformation, ensuring a smooth shift from outdated systems to cutting-edge architectures. Whether it involves transferring applications, data, or entire workloads to the cloud or re-engineering existing infrastructures, a strategic migration approach minimizes interruptions, optimizes resource use, and accelerates the overall modernization process. Let's delve into the key aspects of planning migrations with a focus on modernization and actionable insights to navigate challenges and maximize outcomes. The first step in planning for migrations is recognizing the underlying drivers. Migrations are often triggered by end-of-life or EOL systems, which are legacy systems reaching the end of vendor support. They are also triggered by high operational costs associated with maintaining outdated infrastructure, limited scalability of traditional on-premises systems, and innovation goals to enable modern capabilities like AI machine learning and big data analytics. Understanding these motivations ensures the migration effort aligns with strategic business objectives. Migration planning can be divided into distinct phases that address every aspect of the process. The assessment phase sets the foundation for the migration effort. It involves understanding the existing environment, identifying dependencies, and defining the scope of the migration. The key activities in the assessment phase are inventory analysis, which involves documenting all applications, data, and infrastructure components. Dependency mapping refers to understanding interdependencies between systems to avoid downtime, and workload prioritization involves categorizing workloads based on complexity, criticality, and modernization potential. Automated discovery tools like a AWS Application Discovery Service or Azure Migrate streamline the assessment process. After understanding the environment, the next step is to define a clear strategy for migration and modernization. The key considerations involve migration approaches. Based on business needs and technical feasibility, decide between options, such as rehosting, replatforming, refactoring, or rebuilding. Next is target environment that involves identifying the future state, such as cloud-native architectures, hybrid solutions, or multi-cloud environments. Finally, it is also important to define success metrics, or KPIs, such as performance improvements, cost savings, or reduced operational complexity to measure migration success. The next step is designing the migration plan, which details the technical and operational steps required to execute the transition. The core components of the design phase include phased migration, which involves implementing a phased approach to minimize risks, such as starting with non-critical systems before migrating mission-critical workloads. Then comes data migration strategy, which means designing secure and efficient methods for data transfer, including encryption and validation mechanisms. Next is downtime mitigation, which includes identifying strategies like live migration or cutover windows to reduce business disruption. Finally, security planning means incorporating robust identity management, compliance controls, and threat detection in the target environment. The execution phase involves implementing the migration plan, often using automation and orchestration tools to streamline the process. The best practices to follow in the execution phase include testing, which means conducting pre-migration testing in staging environments to identify potential issues. Automation, which refers to leveraging tools like Terraform or Ansible to automate deployment processes. And finally, maintaining clear communication with stakeholders to address concerns and provide updates on progress. Modernization does not stop at migration. Once workloads are migrated, Organizations should continuously optimize and modernize systems to extract maximum value. The post-migration activities include performance tuning, which means optimizing workloads to leverage the capabilities of the target platform. It also involves cost management, which includes monitoring cloud spending and right-size resources to avoid over-provisioning, and innovation enablement, which means exploring advanced features like serverless computing, containerization, or AI-driven analytics. Despite meticulous planning, migration efforts often encounter challenges. Being proactive can mitigate risks such as data integrity issues. To do this, it's a good idea to use checksums and automated validation tools to ensure data consistency post-migration. Downtime risks can be mitigated by incorporating rollback mechanisms to recover quickly from unexpected failures. Team skill gaps can be reduced or eliminated by investing in training or engaging external experts to fill technical knowledge gaps. Finally, for change management, you can prepare stakeholders for cultural and operational changes associated with modernization. A wide array of tools and frameworks support migration planning and execution. For example, cloud providers such as AWS, Azure, and Google Cloud offer dedicated migration services and tools. Data migration tools like Apache Scoop, Talend, and Informatica handle large-scale data transfers. For containerization, Kubernetes and Docker facilitate the migration of monolithic applications to microservices. And for CI/CD pipelines, Jenkins or GitHub Actions ensure a seamless transition with minimal disruptions. In this video, you learned that migrations are often driven by legacy systems reaching end of life, high operational costs, limited scalability, and the need for modern capabilities like AI and big data. Key phases include assessment involving inventory, dependencies, prioritization, strategizing incorporating migration approaches, success metrics, and designing, which includes phased migration, data security, and downtime management. Execution requires automation and testing, with post-migration focusing on performance tuning, cost management, and innovation, both serverless and AI. Common migration challenges include data integrity, downtime risks, skill gaps, and change management, which can be addressed proactively. AWS, Azure, Google Cloud, and tools like Scoop, Talend, Kubernetes, and Jenkins aid migration, data transfer, and automation.